Going to be a little bit of a shorter lesson today. I'm hoping to give you around half the time of class just to be working, so you can be finishing up test corrections if you need to do that still, or be preparing for a retake if you're going to do that, or be finishing up the positive physics assignment that's due tonight. Whatever you need, and I'll be online the whole time so that you can get help with any of those things if you need it. So that's kind of the plan. We just have a short bit of notes and some practice problems really to go over today. Just a reminder about the retake for the Unit 2 test and the test corrections. Remember that the test corrections give you the curved score. So if you want that curved score on your 9 weeks grade, I need you to turn in the test corrections this week. If you turn them in next week, that's fine. You can still turn them in next week, but they wouldn't impact your 9 weeks grade, just your semester grade. So if that 9 weeks grade is important to you, make sure you get those corrections turned in by this week. If you're going to do a retest, then on Access on the bulletin board page, you can click on the announcement and be reminded of when those retest date and times are. And so no one showed up yesterday, but today, 3:30, you could come today if you would like, and start a retest then. And that would really be your only option if you want it to be on this 9 weeks grade. But you can still take it next Thursday or next Friday if you're not concerned with it being on this 9 weeks. So just those quick reminders. Any general questions about timing or deadlines or timelines before we move into the notes?
So if I wanted to turn in test corrections like tomorrow morning, is that okay? So just like don't wait till last minute if you want the grades to get put in before the quarter.
Well, I'll be finalizing grades on Monday, so as long as it's turned in, well, I'll probably work on it over the weekend, but
Okay.
I have to finalize them Monday. So as long as you turn it in tomorrow, anytime tomorrow, then it'll be fine.
Got it. Thank you.
Anything else you want to ask? All right. So let's jump into the notes. Like I said, it'll be reasonably short today, not a lot of new information to cover. Mainly, I really want to give you some strategies that may help you as you're trying to complete the positive physics assignment, and also just generally strategies that will help you as you're working on solving physics problems moving forward. So these are just some suggestions. If you want to write it into your notes, you can, but there's really 3 things I want to highlight here. When you're reading a physics problem, whether it's on positive physics or whether it's on a worksheet or on a test or quiz, there are some key words you want to look for, and 2 really common ones are constant velocity and at rest. If you see either of those phrases, then that's an important thing to recognize. If it's constant velocity, then there is no acceleration. And so keep that in mind. All of these equations that are based on acceleration basically simplify down. So equation 1 just becomes Vf equals Vi. The initial and final velocities are equal if there's no acceleration. Equation number 2 just becomes displacement equals Vi times t. Equation number 3 just becomes final velocity squared equals initial velocity squared because it's not changing. And equation number 4 basically doesn't have acceleration in it, but the velocity and initial and final velocities would be equal. So you would just be adding them and dividing by 2 to get an average, which is kind of redundant, but it's fine. It will still work actually. But if there's constant velocity, then the acceleration is not going to be applied. It's going to be 0. If it says at rest, then one of your velocities is 0. Often it'll say began at rest. Sometimes it will say it stops or it coasts to rest or comes to rest. So if it says it starts from rest, then initial velocity is 0. If it says it stops or comes to rest, then the final velocity is 0. But that phrase at rest is going to give you a hint for a lot of questions. And then I would encourage you to just write down these 5 variables on the side of your paper whenever you're trying to solve a problem, and put beside each one what it's equal to, or put a question mark if it's the one the question is asking you to find, and then either leave it blank or put NA or something like that if it's not even mentioned in the question. In terms of the equations we've learned, we've already gone over equation 1. We took notes on that last week. And we've gone over equation 2. We took notes on that on Monday. And then for equation 3, that's the one today that we're going to talk about. Equation 4 is not one of the College Board equations that they give you, but it is one that we derived in our notes on Monday. So for equation 4, this is a reminder to you that whenever we cover an equation that is not listed on the formula sheet from College Board, it's wise of you to highlight that, put it somewhere in your notes. I always recommend actually using the physics formula sheet that you have. Hopefully you've printed it. On the one side, it's half blank. And I just encourage students write all the equations that I give you that are not included in that half blank space. And this fourth one that's based on average velocity is not given to you. It's not on the equation list from College Board. So you want to put it on that half blank side so you don't forget. That's one that could help you that they're not giving you. There's really never a problem that you would need to solve where you would have to use equation 4 on this list. But it might make the problem a lot easier if you remember it. Now, if you haven't printed your physics constants and equation sheet so you can't write it there, maybe just put a page at the end of your notes or at the beginning of your notes where you just, that page is for key things that you just want to list. And you always know when we have an equation like this, you're going to put it on that first page in your notes or that last page in your notes. Whatever it is, don't just put it randomly in your notes and hope you can find it later. You're going to have a lot of notes. So I would pick a centralized location, a single piece of paper where you always put them, or on the bottom half of that one side of the physics constant sheet. Somewhere isolate those. And this is the first one. This fourth equation on this list is the first one that we've learned that College Board doesn't give you, right? So I would suggest highlighting that somewhere in your notes. Any questions about those suggestions? Just some strategies, some things to keep in mind as you're solving problems. Okay, let's take a look at the third kinematics equation then. This third one is the one we're going to cover today. And you may notice right off the bat, it has final velocity, initial velocity, but they're both squared. It has acceleration and it has displacement. It does not have time. So this equation is handy when in the problem they don't tell you the amount of time and you still need to find one of these other variables. So this equation, actually, we're going to not really go through a full deriving of it. I'm just going to basically tell you how it gets derived as opposed to walking you through all the steps. I have written out all the steps and I put them on axis. I'll show you that here in just a minute. But let's talk about how it gets derived. So the third kinematics equation is basically taking the first two that we've learned and putting them together to cancel out the t. And you could do that a lot of ways. You could try to use an elimination process, but substitution process is the way that it's most easily explained, I think. So if we start with the first kinematics equation, we know it's VVAT. The final velocity is initial plus a times t. If we just solve for t, the first thing we would need to do is subtract VO from both sides. And then we would need to divide both sides by a, and that would isolate the t. So again, the reason we want to isolate the t is because we're trying to create an equation that doesn't have time in it. That way we can solve problems where the time is unknown. So we isolate the t, and now we're going to substitute that in to equation number 2. So if you substitute VF minus VO over A into the t here and to the t there and then square it, and you break down the algebra, so you'd have to square it in the one and then just multiply it out with distributive property in the other. You have to go through a fair number of algebra steps. I'm not going to show you that all in class in the notes today, but this is what it ends up doing. It cancels out the t's. So this is, like I said, I'm not going to walk you through it because it's a lot of algebra, and I don't know that it's a great use of our time, but I would challenge you to maybe try it. See if you can do the algebra. It's good practice. College Board always asks you to do equation derivations, and often they'll ask you to solve equations for a given variable. So it's good practice. If you want to do that and you want to check and see if you're on the right track, you can go to Axis. So let me get that ready. And if you go to Axis under Topics, we are now in Unit 3. Down here in the bottom right-hand corner, you can see Unit 3 goals, review sheet, solutions to the review sheet, and then scrolling down a little bit further, here it says deriving kinematics equation number 3. So I've just written it out and put it in here as a picture so you can look at it, see the algebra, check, and if you want to try it yourself, you can see if you can come up with that same solution. All right, so that is an option. You can look at my work there. Now, while we're on Axis, just a few comments. We are rapidly closing in on the end of Unit 2. We already have covered all the notes. We just have to practice starting next week. We're going to do some lab practice and some worksheet practice. But today is really the last bit of notes. So as you start thinking about this 5-day weekend coming up, if you have some extra time and you want to start just early preparation for that test, it won't be next week, but I need to look at the schedule. We might have it on that Thursday and Friday the week after. In fact, that's probably the best time to shoot for. So it won't be next Thursday or Friday, but the Thursday or Friday after that. So Thursday for you guys. So you may want to go ahead and start preparing while you have a little extra long weekend. But there's several webcasts on here. There's the one that was specifically about the summary sheet that I challenged you and encouraged you to use. But underneath that, you'll also see quantitative kinematics graphing. So if the velocity time graphs, position time graphs, if that's been confusing for you or it's been a struggle, watch this webcast and the PowerPoint and PDF slides right below it that go with that webcast for extra review. Over here on the right, there's a deriving kinematics equations webcast with its associated notes right underneath it. And then below that, solving equations symbolically webcast with the notes right underneath it. Those are all good things to be reviewing. They're resources that we don't have time to go over in class, and I don't necessarily assign them, but they're great for you to use. They're great resources for you to use to prepare for the upcoming test on Unit 2. You need to spend time outside of class preparing for a college board level, AP level class. And so those are some resources I provided for you to help you. There's also one over here, but I'm going to actually be asking you to do some of this one, this tangent lines webcast. That's actually something I'm going to be asking you to do next week anyway. So, but there's that one too. So there's several webcasts with notes. Just encourage you to be using those resources. All right, back to the actual notes. So like I said, not going to show you the algebra in class, but I wanted you to see where it comes from, how they derived it. All right, let's practice using kinematics equation 3. So as I mentioned earlier, I would recommend you write down all the variables and list what they are, and then figure out how to plug them into the equation. And just so you know, right now we just looked at equation 3, and so obviously you're going to use equation 3 to solve this question. But today we're also going to practice what if they don't tell you what equation to use, which is the normal. Normally when you're taking a test, they don't say use this equation. You have to figure it out. I'm telling you which equation to use right now because I want you to get comfortable with how to use it algebraically. So take a couple minutes, read the question. You might want to jot down what numbers go with each of these variables and then plug it in and get your answer. And then when you have an answer, type your answer in the chat. All right, starting to get a fair number of answers that agree. Just over here on the left, all I've done is just show you, this is how I would write things down. I put the question mark by what I'm supposed to find. I put the numbers by each matching variable, and I just put NA by the ones that are not mentioned or not asked about at all. And it's, like we said, this third kinematics equation is designed to be able to solve for these variables without knowing the time. So we don't know anything about the time, so this is the perfect equation to use. And if we plug the work in, it looks like most of you have been able to do that successfully. So any questions about this example? All right, let's give you one that's just maybe slightly more complicated. Well, not really more complicated, but instead of asking you for the variable it's already solved for, see if you can do when it's asking you for a different variable. So a car accelerates from rest to 30 meters per second while traveling a displacement of 20 meters. What was its acceleration? All right, seeing quite a bit of consistency here in the answers coming forward. Again, just showing you how I would list the items there by their appropriate variables. On this one, the main change is we're not solving for VF squared, we're solving for acceleration. You'll notice because the VO is 0 that part of the equation cancels out, so it simplifies down to final velocity squared equals 2a delta x. So the acceleration would be v squared, final velocity squared, divided by 2 delta x, and we do come up with a positive 22.5 meters per second squared. Any questions about this example?
When you're showing your work on the test, can we plug, like I plugged in the values before doing the algebra, is that okay?
Yeah, College Board recommends that you do the algebra first and then substitute, but you don't have to do that. You can just substitute it in and then do the algebra.
Okay, cool, thank you.
What they do require, again, just a reminder, I've mentioned this before, but just a reminder, they do require that you write the equation first, whether you solve it algebraically for the correct variable or not, and they do require that you show the substitution. They actually don't require that you show how you manipulated algebraically, but you do have to show the equation unsubstituted and then the equation substituted, whether you have manipulated the equation or not. You need to show those two steps. And almost always that's 2 of the points for the grade. Anything else you want to ask? All right. So the next thing I want to cover is what about when the kinematics equations are just mixed up? Like so far we focused on equation 1, then we practiced that. We focused on equation 2, then we practiced that. Today we focused on equation 3 and practiced that. What if they don't tell you which equation to use? How do you figure that out? Well, there's some key things I want to make sure you're tucking into the back of your brain. So again, this is not so much notes about new information. It's ways to organize your thoughts, ways to be strategic and efficient. So one thing that I would keep in mind is we know these kinematic quantities. We've learned them. And you should have very solid in your brain what the units are for all of them. Because sometimes they won't just flat out say the acceleration is something in meters per second squared. They'll say they'll use different phrasing like the rate of change was, or something like that. So they don't actually use the word acceleration. But if you see the units meters per second squared, then you know that is the acceleration. Okay, so just some little subtle things like that to keep in mind. The other reason making sure you really know these variables and units clearly is when you're doing the dimensional analysis for your problem and making sure the units work out, you can see if your answer is logical. So if the question asks for time, but when you check your dimensions, you get the unit meters, then something's wrong. You either checked your dimensions incorrectly or you set the problem up incorrectly. So if you want to make sure you always think about what the units are for these variables and double check them. It can give you a hint as to what the number in the question's giving you. It can also help you check your answer to make sure that your process was logical and dimensionally correct. All right, the second little strategy is we've basically learned these 4 equations. The first 3 are given to you by College Board. The fourth one is not given to you by College Board, but it's one we derived on Monday. But if you notice, in each of the 4, there's something different missing. So in the first equation, it doesn't have anything to do with position. In the second, it doesn't have anything to do with final velocity. The third doesn't have anything about time, like we just mentioned today. And the fourth one, which we haven't really used, and really honestly, seldom would you need it. Well, technically never would you need it, but sometimes it makes things a little easier. But so it's kind of handy, but pretty infrequently used. Anyway, it doesn't have the variable acceleration in it. It doesn't mean there's no acceleration. There's an initial and a final velocity. The only reason that would make sense is if it's changing. So there is an implied acceleration, but it's not known and it's not asked for. So the reason this can help is if you're reading along and the question says nothing about time and asks nothing about time, you probably want to start looking at equation 3 as your first strategy. If the equation says nothing about final velocity and asks nothing about final velocity, your best strategy is probably to start with the second equation. So it seems a little bit counterintuitive maybe, but look for what's missing. And when you recognize what's missing, that can help you pinpoint which equation would be the best one to try. Okay, so I'll kind of help you walk through that logic on this first one, then have you solve it, and I'll have you try 2 on your own. So let's look at this next question. An arrow is projected by a bow vertically upward with a velocity of 40 meters per second and reaches a target in 3 seconds. How high is the target located? So if we think through what we know and don't know here, the arrow is projected by a bow vertically up with a velocity of 40 meters per second. All right, so I know the initial velocity is 40 meters per second. It reaches its target in 3 seconds. Okay. I know 3 seconds. How high is the target? All right, that's what I'm looking for. Does it tell me anything about the acceleration? No. So there's nothing there. It doesn't ask about it, and it also doesn't say anything about it. Does it tell me anything about the final velocity? No. So there's nothing given, and I don't know, I'm not asked anything about that. So as I think through this question, if I look back at the previous problem or the previous list, the 2 things I'm missing are V, F, and A. So let's look at number 2. Do we know the delta X, or is that what I'm being asked to find? See a few people. Yeah, it's what's asked. Do I know the initial velocity? Yeah. Do I know the time? Yeah. So the only other thing I'm missing is acceleration. Is there anything about this question that could help me figure out either the final velocity or the acceleration?
The vertical.
I didn't hear the end of that. Can you try again?
It's saying it went vertically up in the air,
Mm-hmm.
and um, it's saying when it reached its target, so it means it had a negative acceleration up into the air.
Okay, good. So we know that the acceleration is going to be negative. So
And would the acceleration be negative 9.8 meters per second squared because that's the gravity of Earth, right?
there we go. Good. So gravity is what's going to cause it to slow down. So it's basically like the free fall scenarios that we talked through before, how we can use that acceleration. So it's not given in the question, but because of this vertically, there's that hint. All right. So now that I know those things, and I see it doesn't say anything about final velocity, I don't know anything about final velocity. Some students get confused. They'll say, oh, when it hits the target, the velocity is 0 because it stops. But that's not, we're not talking about after it hits. Whenever they say final velocity, it's always right before contact. So we really don't know anything about final velocity, and they haven't asked anything about final velocity. So if we use that knowledge, we can choose to use that second kinematics equation. Notice that they've put it like College Board does with the X final and X initial, as opposed to the delta X like I prefer, but the X initial would just be 0. Before it starts moving, its position would just be the 0 mark for simplicity. And we know the initial velocity and the time, 40 meters per second and 3. We know the acceleration is due to gravity, and we know the time is 3 seconds, and it would have to be squared in this 1/2 AT squared part. So we know everything that we need to know to fill in the right side of the equation, and we can figure out the displacement would be positive 75.9 meters. It's 75.9 meters up is where the target must be according to what they've given us. All right, any questions about this example? Just wanted to kind of talk you through one to help you sort of understand how you have to recognize. Sometimes they don't tell you just actual numbers. You've got to kind of figure out from the context of the question some things, and then by what's missing and what you can't intuit, what you can't infer, choosing an equation that will make it efficient. Now, I do want to encourage you and reinforce this fact. You don't necessarily have to choose a certain equation. If you choose the quote unquote right equation, it just makes things easier for you, more efficient for you. If you choose the quote unquote wrong equation, it just means you might have to do a 2-step problem. And it's not really wrong. It's just going to give you more work and be less efficient. All right. So, and on an exam with AP Physics, time is really one of the things you have to keep in mind. And so the more efficient you can be, the better. So that's just a couple strategies to help you. Let's have you practice figuring out which equation you should use and solving a couple of problems. So an object accelerates from rest with a constant acceleration of 8.4 meters per second squared. What will its velocity be after 11 seconds? So see if you can think it through, maybe make your list of variables, figure out what's there, figure out what's missing, choose an equation and see if you can solve this one, and then put your answer in the chat. All right, looks like a lot of you coming up with the same answer here. So if I make my list, I see I'm looking for final velocity. I see there's no mention of position anywhere in the question. So if I go back to my equations, the one that's missing x is the first one. And so we can see, does that first one make sense? Well, VF is what I'm looking for. I know VO, I know A, and I know T. So that sounds like a pretty good choice. And if I take a look at that first equation and substitute in 0 for initial, 8.4 for acceleration, 11 seconds for time, I do find a final velocity of positive 92 meters per second. All right, any questions about this example? All right, let's try another one. We'll wrap it up with this one, make this one your last practice here. So an object accelerates from rest to 34 meters per second over a displacement of 70 meters. What was its acceleration? So there's your list. Think through what equation might help you, solve it, and put your answer in the chat. Seeing a little more variety in our answers here, mostly coming up with 8.26. In our list of variables, we can see acceleration is what we're trying to find, and time is not mentioned at all. So the equation that ignores time is the third one. So that's probably where I want to start to see if it makes sense to use that one. And if I look at that third one, I know the final, I know the initial, I know the time, I know the displacement, and I'm trying to find the acceleration. So that one seems like a good strategy to choose. I do need to eventually rewrite it, whether I rewrite it initially and then substitute, or substitute then do the algebra. But my initial minus final velocities would be the 34 squared minus the 0 squared. And then it looks like maybe a couple of you forgot the 2, or either multiplied or divided incorrectly with the 2, following through to figure out the acceleration. So the acceleration should be a positive 8.26 meters per second squared. Any questions about that example, or how to use some of these strategies that I've shared with you today? All right. So that was the goal for today, is to introduce you to the third equation, remind you of a couple things on axis, give you a little bit of practice with the third equation, and also just with figuring out how to use the equations appropriately. So as you're finishing up positive physics assignment, the assessment for Unit 2, remember, you don't have to do the work section, just the assessment. Although the work section could help you a lot, it's not required. Don't forget a couple of reminders about positive physics. You have to click the check answers button to save your work on each question. So you can't just do it at the end. You have to click check answers for every question. You don't want to click finalize until the very end. And then when you're done with all the questions, then you click finalize, and then you can go back and make corrections. And your grade will be the average between your first score and your corrections. So if you go back and correct them all, you should be able to get 100% in corrections. And so if you got a 90 and then corrected them all, your average would be a 95. If you got an 80 and then corrected them all, your average would be a 90. And so your final grade will just be the average between whatever your correction score is and whatever your original score is. But you can't do
Oh.
corrections until after you finalize.